For the agenda, we'll start with discussing what mission math is, then we'll go straight into the panelist intros, and we'll also introduce ourselves as a host. We'll do the actual panel discussion, which is an interview style, discussing the intersections between math and medicine with our panelists. And then we'll wrap up with a Q&A, which is using a website called Mentimeter, where you guys can anonymously submit questions that you have for the panelists. Okay, so for our hosts, my name is Ria. I'm the co-founder of Mission Math, and I'm your first host.
I'm Saranya. I'm the other co-founder of Mission Math, and I'm your other host.
I'm Asmitha, and I'm a tutor at Mission Math, and I'll be moderating our chat today for today's panel.
If you have any questions at all, you can just throw them in the chat, and Asmitha will get back to you.
Okay, so what's some background on Mission Math? Well, Ria and I started Mission Math in December of 2021 as a middle school IB community project. We basically really loved what we did working with the fifth graders at our school and wanted to take it a step further, and now it is Mission Math.
So like Shani said, since that community project, we've grown Mission Math into an international organization. It's a youth-led organization that celebrates students' strengths while tackling areas of weakness to increase math learning and thus improve students' confidence, combating the lack of confidence caused by underperformance in math.
Our mission statement is a little bit of a mouthful, but it essentially just boils down to helping students increase their self-esteem so their academic performance increases as well. And as of April 2025, we have had over 1,500 student registrations. We have expanded our online reach to over 160,000 people in 36 plus countries. We've held 12 workshops, and we've had 6 summer camps across 2 summers.
For our services, we offer tutoring, which is our main service. That's year-round. So we offer school year courses, which are from September to May. During the school year, they're on weekend mornings. And then we also offer help sessions, which are one-on-one, and they're typically 30 minutes to 1 hour. And then we offer workshops, which explore the real-life applications of math. We host those typically on a monthly basis, and they are typically 1 to 1.5 hours. Finally, we host summer camps, which are during the summer. This year, they'll be from July 7th to August 1st, and Smith will actually send the registration link right now in chat if you want to register. This year, they'll be from Monday to Friday, 1 hour each day, and you can choose your class time at registration. And this year, we're offering pre-algebra, Algebra 1, Geometry, Algebra 2, and pre-calculus. So we have 2 new summer camps this year. And again, registration is open, so you can register quickly right now. And all of our services are 100% free and virtual. So they're accessible even if you have summer plans or you'll be out of town, anything like that. They're fully accessible to everyone. For volunteer opportunities, we offer high schoolers to join our team. So we have right now 45 plus team members across our sub-teams like public relations, social media, tutor, and marketing, along with interactive systems, which is a new sub-team. You can also join our community by being a volunteer, which is less of a time commitment. It's more flexible, but you help out in these different sub-teams with occasional tasks. And you can see some pictures here on the left of our team. Okay, Harold, you can introduce yourself. He's our first panelist.
Hi, good afternoon or good morning, depends on where you are. My name is Harold. I've been doing mathematics for all my life since my bachelor degrees in mathematics. I moved to US after get my degree, and then I study mathematics statistics in particular in my master degrees and PhD degrees. So since then, I found a job at a nonprofit healthcare facility, doing a job as a biostatistician. Later on, as moved to Boston area, as I'm now working with Pfizer. So my day job is to use mathematics actually every day. But also I use mathematics in my regular life, calculating discounts as I mentioned. Of course, those are all the numbers. So happy to talk with all of you. Thank you.
And now, Vibha.
Hi, everyone. My name is Biba. I grew up in Redmond, Washington, and went to high school there my whole life. And now I am a third-year biomedical engineering major at Georgia Tech in Atlanta. And I've always been super interested in math and science my whole life. So I'm super excited to be here today. I have a little bit of experience so far. I've done some research here on campus that was working on cancer research, and now I'm also interning part-time at a startup here in Atlanta that's working on nucleic acid delivery and kind of making that more effective. So I've had some experience there in like running assays to kind of evaluate immune responses. And yeah, I'm super excited to talk with you guys today.
Okay, thank you, Harold and Viva. So now that we've wrapped up the introductions, we're going to go straight into the panel. So I'm going to stop sharing. Um, and we're just going to go straight into the questions. So Saranya will start by asking the first question for the panelists.
So we'll start off really basic. Were you always good at math?
I will start first. I don't think so. I'm always afraid of math since I don't know. My going back to my elementary school, probably. I think it is not a human nature to play all the numbers. I think, as a history of the mathematics, it's always the wisdom people, right, who play around with numbers, come with theories. And I think it is a challenging because it actually asks you to sit down for a long time to think through all these numbers and how they manipulate and how to figure it out, especially when going a little bit more on the mathematics on the proofs and other things. So it's not a natural transition from the natural world to the mathematics. It's a highly abstract course or highly abstract uh, materials you have to comprehend. So it does need you to change sometimes your behavior and also follow instructions, which are not always are interesting to do that, right? So I would say no, not always interested. But once you break through yourself, actually, um, well, you need a good teacher, by the way. I think this forum here would be a great access to those individuals and students who are already being successful in those areas to help you through some of the difficulties. I think that's crucial because sometimes it doesn't matter which subject you do, we always stop the one we see the first stomp. Um, if somebody can help you go through that, I think will be make your journey a little bit better, a little bit more fruitful in a way. Not to mention, I have been in math for a long time. Even if I finished my degree, bachelor degree in China, when I moved to US and there's another transition, for example, language-wise, I don't understand a lot of the mathematical terms used here. So you have to relearn kind of thing by mapping whatever you learned to whatever you don't know, or you knowledgeably you probably know, but logistically you don't quite understand what is the context about. So you have to relearn some of those, and those are I would say, the capabilities, adaptabilities you need to have. Further, maybe the questions will ask about that, but happy to chat more about that. Thank you.
Yeah, I would also say I definitely wasn't always good at math. I will say though, I think I've always just been more interested in math and science like growing up. So I definitely put more effort into those classes than I did versus like humanities. So like I think in high school and everything, I did well in my math classes, but that's because I took the time to practice it and like build those skills. And I also think I'm a pretty logical person, so I enjoyed math just because like you could find the logic and the patterns and like how to solve a problem, and then you could just apply that to those same problems. So I kind of like enjoyed that, but I think when things got a little more abstract in math, that's where I struggled. And I kind of had to force myself to really ask questions like, oh, why are we solving a problem this way instead of just memorizing formulas and like not really thinking about the reasons behind it. So that definitely helped. But I would say I don't think it really matters if you're naturally good at math or not. It's just more important if you like make sure you build that skill early on because it definitely is a super, super important skill in any job you're gonna have in medicine. So I think it's just important to build that skill early on.
Yeah, I fully agree. I think math is really just an area where it's about hard work and the work ethic that you really put in, as opposed to naturally being talented or gifted with math. I think that can definitely help with like having a passion. But a lot of it really just comes down to practice, which at Mission Math we really try to focus on. Um, okay, so the next question is when did you know that you wanted to pursue a career in medicine? And the question is also in chat.
Yeah, it's a quite interesting question because when I finished my graduate school, or when I finished my bachelor, I figured out what to do. I used to be a math teacher during my training at the bachelor degree, so I taught a lot of high school students. I taught a lot of being a monitor teachers in the classroom, helping students out. So after that, I have to make a decision what I'm gonna do. I decided to have my postgraduate studies in the US. That's where I landed. Again. I got my degree in 2008. I don't know if you have been born in the year yet there, but basically the job market is pretty bad to the low point. So I have to find a job. And one of my concentrations during my graduate studies is study the human genetics. So the statistical models on the genetics. Right now, currently you probably hear more about the genetics sequencing, right? It's everywhere. You know what? For example, 23andMe or the Ancestry.com. Those are the sequencings. But back in my days, it's not. So I was lucky enough to, after numerous interviews, and land a job in Wisconsin. That's my first job. Actually to do my studies there. So that's my first engagement with healthcare. But I would say that healthcare had many, many facets, perspectives. So medicine is a huge field. Healthcare is above that. So not only you do medicine, and it depends on who you talk with. Sometimes people think about medicine as a patient-provider relationship. Sometimes they talk about medicine research, which is totally different field. I'm happy to go into details of the differences. And also another big part of the medicine is the drug. It's a company I worked with right now, for example, developing the COVID-19 vaccine. That's another different part of the game. But mathematics is applied for all of those fields. I'm happy to go into any one of those fields and share with some of the experiences I have.
Yeah, I think for me, I don't know if there was like a set moment when I was like, I want to pursue a career in medicine. I think it was a buildup of a lot of things. I remember like the first time I really like found out I was interested in science was probably in sixth grade when we did like a genetics unit in our science class. And I remember that was like the highlight of my day every day in that unit, like going to science class and getting to learn about genetics. I was super, super interested in it. I remember we used like the Punnett square for predicting like eye color and like hair color based off the parent genotypes. And I had never really felt like that excited about a class before. So that definitely stood out to me. And then I guess I kind of just kept that interest in mind as I went through middle school. And when I got to high school, I really just tried to take as many classes as I could in science. Like I took AP Bio, AP Chem, AP Physics, and I enjoyed all of those classes. And then I remember in high school, the CRISPR won the Nobel Prize, like for gene editing. And I thought that was super interesting because people were talking about it being used for like therapeutic applications and treating diseases. So I was like, okay, like I could use this interest that I've had that I just thought genetics was interesting, but people are using it to treat people. So I thought like, wow, I could actually have a career out of this. Um, so I remember I wanted to just learn a little bit more about like gene therapy. So I did an independent study on gene therapy, which is basically I had like one of my high school teachers mentor me every week, and we'd kind of go through a different article and like case study about gene therapy. So I really got to learn more about the actual science behind gene therapy, and it was like a very new topic at that point. So I remember it was just a great way for me to like explore that interest more. And that's, I think, what finally solidified like I wanted to pursue a career in medicine. And that's what led me to apply for bioengineering majors for my college applications.
Yeah, definitely. Like I also remember, I think in like eighth grade or something, we did a genetics unit and it was so much fun. And Harold, kind of building off of what you said, our next question is, what inspired you to combine both math and medicine in your career?
Yeah, that's a really good question. I will start a little bit smaller. I would say in my research during the time when I was in the healthcare systems, There are three things I want to share. The first is in order to support your funding, right? All the institutions has to demonstrate the capabilities of the what results are impactful to the patients you serve. So in that way, quantitative methodologies like mathematics or statistics will help you get there. But the question is that statistics and mathematics alone will not get you there. It's actually in collaboration with the domain experts, for example, the surgeons or biologists or microbiologists who study, let's say, emergency medicine of the infectious disease will actually have the questions. So the mathematician or statistician is working, collaborating with the providers to formulate a good question to answer. So that's very important. And also, if I don't know if you what classes you took, but if you take any of these physics or chemistry classes, or biology included, most of the materials are focusing on experiments or observations. You see something happens, you record it, then you try to come up with some general conclusion. But a lot of the times, and the conclusions you came up with several samples or several experiments are biased and it's not complete. The mathematics is a way to compensate on the limited data you have, or maybe a pointer to what kind of more data, what type of data, more data you want to obtain to fulfill a less biased conclusion of your model. So, in generally speaking, mathematics is a very logical, very methodological way to study something you don't understand. Actually drives you to ask more questions. That's the third point I want to bring. Usually, as I started to struggle with mathematics, and what I really struggle is the way how we build our thinking, arguments. How do we use limited, if you still remember, limited theories or axioms you learn to actually come up with a beautiful solution, simplified solutions for the problems you have, which is very complicated. But you build small steps, and when you up to the point you find out the answers to the question. The way how the difficult sciences or the formulations is exactly the same way, even though sometimes we are using biological language, sometimes we're using chemistry or chemical language. But mathematics, if you have the training, will help you to facilitate a lot of these arguments and curiosity. I think that is the backbone what I learned from mathematics. Um, Sometimes we are so focused on something we do. Don't forget, not everybody was having the math training. So when you try to explain yourself to people, please be gentle. Don't just speed out all the formulas they don't quite understand. Please talk with your collaborator to see how to best present.
I also think this is a great question because I definitely thought for a while like math and medicine do not go hand in hand. Like they're very separate. Because like on one hand you have math and it's like super logical, super structured as Harold said. And then you have like biology, which is it's always constantly changing and you can never fully get an answer. You could always have more questions. So I never really thought about combining those initially. But I've seen like in my experiences throughout college, like in my job right now, I do a lot of like wet lab work. Like I run experiments for testing like data or testing samples from preclinical trials. So there's a lot of like bio work there, but also that experiment is run to generate data and to get mathematical values to actually quantify if our therapy is working. So the two really do work together hand in hand. You can't really have one without the other. And I think it's really, really important to not underestimate the importance of math in medicine because we would not be able to really precisely quantify any of the work we're doing if we don't have that data analysis and that statistical analysis on the experiments we run.
Yeah, I fully agree with what you guys said. And I found, Viba, what you said about like when you got to college, like that's when you really start to see these intersections. I found that really interesting because I think we see that a lot with our students also at Mission Math, where with the way that, the K to 12 like education system is structured, make math so different. They make it an entirely separate class, and biology is its own class, and they don't really explore these intersections between these different subjects. So I think a lot of that is like when you get to the higher education is only when you really start to see how these connect. Which is something I think is really important that the education system focuses on these intersections within like elementary and middle schools, because it's a really clear connection and it can help a lot of kids have a passion for math if they understand its applications. Um, so my next question is, how do you use math in your day-to-day life?
Sure. I will keep it a little bit simple, seeing that I have to, in my immediate job right now, I have to talk with collaborators to see what the questions they are interested to answer. Then I have to read some of the background materials to understand, okay, this is the data they have, and this is the question they have. Then the first thing is not doing math. The first thing is to evaluate whether the data collected answer the questions they gave it to me, right? So usually here's a little tip for people who are looking for part-time jobs or tips. The first thing you should evaluate is not how to do the problem. The first thing is to evaluate whether the whatever you are given the material, will that be relevant to the questions you're asking. And people always forget about that. That's the simplest thing. And that's the easiest thing you can do to impress people is to see, okay, here's the data you give it to me. Here's the question you want to answer. Do I really understand the question? Do I really understand what the data collected? Is there any relationship I can demonstrate? So that one comes back to a very important point, where is the logical thinking is always coming through asking, evaluating the questions you are given, not just jumping to the formulation of how do I solve the problem. You may spend your day solve the problem, but the problem then you find out, okay, the problem is not relevant to the data you have. So all the 1 day work you probably wasted. So I would challenge everyone here, including myself, to actually think about not like the homework problems is already formulated for the materials you've been taught for the week or for the day. That's a little bit different. I totally agree. When you in the real situation, for example, when you go into the store buying things, I will use discount. And if you don't like certain um, you know snacks, the discount may not work for you, right? Let's say, well, if you like ice cream, if you see the ice cream discount, have 50%, you're gonna jump on that, right? So the first thing is to understand what questions you're asking, what questions you're trying to solve. Is that the data collected for the question?
Yeah, for me, I would say like in my day-to-day life, I definitely use like math like in my work for sure. Like when I'm running my experiments, for example, like the main experiment I run is called an ELISA, which is basically to like detect proteins in a sample. And I always have to calculate like standard curves in this. So I sometimes have to apply like logistic regression to calculate the unknown concentrations in my samples. So that's like a big one. Also, even just super simple things though, like preparing solutions for my experiments or like diluting samples, like those require just basic knowledges of like ratios and unit conversions and like dilutions. And of course, all of this sounds really simple, but it's always really important to keep it precise, especially in these experiments, because even a small mistake can affect an entire experiment. And especially like working at a startup where things are super fast paced afford to make small mistakes like that, as you don't really have the time. So I've definitely had to make sure like I can't get rusty on those like basic math skills and keep those at the front of my mind. I think even just like super simple though, like keeping track of my expenses, like budgeting in college, like keeping track of like my groceries and if I eat out food, like just making sure I'm keeping track of like all the money I'm spending. I have like a spreadsheet in Excel. So math is always just it's super helpful for even just like super simple day-to-day things as well.
Yeah, definitely. I think it's really interesting how both of you kind of brought up a contrast. Harold was talking a little bit more about the abstract, thinking about how to approach these different kind of problems through first of all understanding the question, which I think is a really interesting way of looking at it, as I've personally never thought of looking at first the question and trying to understand what the question is. Um, I've always gone straight to trying to figure out how to solve the actual question first. So I thought that was really interesting. And then Viba bringing up, logistic regression solutions, that sort of thing, especially working like AP Chem right now, where we are doing like, a little bit of, titrations and stuff like that, where we're working with really precise numbers. So I think that's super interesting. Um, and this kind of leads into a little bit of our next question, like, do you have any advice for students who are interested in studying both mathematics and medicine, both on like, the mindset level and then the skills level as well?
Yeah, so for the mindset level, it's probably very chic. It's never give up, right? You, mm, our education's, well, I should say the U.S. education system tends to be very versatile in a way. You can pick whatever you like and do that. But sometimes when you start with mathematics, it doesn't work because, as I said, mathematics needs a different mindset. It has to be persistent and consistent, whatever you do, and don't give up. And that's also implicate that you should ask for help when you're stuck. And yes, working independently is important. I'm not degrading working independently, but working a group, in a team, and also work by learning something by teaching. I think that's a great way to find new friends, meet new people, and also get your own hard problem solved together. What I encourage my kids actually do is to help other people to do understand and discuss why you think this way is better, why you think this way doesn't work. I think we all learn from our mistakes, especially the ones we always make. So by working the group, by doing a little bit more persistent on the problem, and ask yourself, do I really understand the problem, or do I just want to just get going for next one. So I think that's important. Um, skillfully, I think it really depends on where you are on your mathematical journey. I think for technical part of it, you should. I was told, I don't know it's right or wrong, but I did test it when I was in my junior and senior high school, is that the early mornings, usually 8 to 9 o'clock, is the best time to study mathematics, and also nighttime, 8 to 9 o'clock. One of the things I did try is 8 to 9 at night. I think it's reasonable because it's quiet. You should find a place where it has no or limited disturbance to you. Don't keep your cell phone, please. If you do some pencil paper mathematical formulations, and try not to look at your cell phones or other things, and keep the distraction to the low level, will help you to concentrate and focus. It is hard. I'm not saying it is easy, but I think it's very beneficial as well. You will receive a lot of you will be able to focus, and it's not only for math but also for other subjects as well.
Yeah, I think also I would say like my biggest piece of advice would just be to like put yourself out there, like explore as much as you can in both fields. Don't like box yourself into, oh, I'm going to be a math person or I'm going to be like a science person, because I think it's becoming really important to be a person who can do both. Like that's a much more valuable skill set to have if you can be good at both of them. But yeah, I would say like if you're in like middle school or in high school, just like try taking classes in both, like maybe take like one math or one like calculus class, like one biology class at the same time, like see if you have interests that kind of overlap in both. And just like, I don't know, like actually just like try to figure out what you're interested in, but also like if you don't know in high school, that's like totally fine. Like that's what college is for as well. And there's a lot more opportunities, in my experience, at least in college, to kind of explore what you're interested in. But I would say now just like really stay curious, like try to find out like what really makes you want to keep learning, and like what really sparks your interest. And if you can find like an intersection between math and medicine, like even better.
Can I add one more point? Um, to the conversation is very important, I think, is to really evaluate how much time and don't over pressure yourself to get AP or whatever. I think interesting is the best teacher, but also be truthful and be appreciative of yourself, the hard work you have put into any of the subject. Because under pressure, under enough pressure, that's good. Under too much pressure, that's not good. Not good at all. If you I can give you numerous papers talk about the pressure and actually efficiencies of how studies are that, and also your whole body immune system will respond differently if you under tremendous pressure. So enough pressure is good, but don't over pressure yourself to set very high goals that you always lose, and those type of down spiral kind of aura is not good for you. So I just want to emphasize that.
I really like, Harold, what you said about that pressure. We were talking about that in AP psychology just yesterday. The importance of having the exact perfect amount of pressure for optimal performance. And then I also loved when you talked about studying strategies, like going through discussing, teaching, like collaboration. Because all of that is really important, and a lot of the time students try to rush that process of studying, but all of those small steps are really important in your overall learning process. And then Viba, I also loved what you said about not fitting yourself into a box. Because I feel like that's also a bit like a common thing that, middle and high schoolers do, where they think they want to do one like career pathway, so they only take classes and really that like domain. But exploring a bunch of different areas is really important to discovering like your interest in math and medicine, finding a specific area of this intersection that you want to pursue, or even finding other fields that maybe you're more interested in. Okay, the next question is, with the rise of AI, how do you think AI might change the medical field?
It's a very big question. I as a mathematician myself, I think AI is definitely a double-blade sword in a way where if you use it wisely, it help you to get to what you want to learn faster. But if you use it more, not be careful, I think you will be stuck in the gaps between the reality or the virtual. There are a lot of articles and there are a lot of conversations about how the generative AI or in generally AI models or AI virtual realities are impact our studies, impact our brains. I strongly suggest all of us reading some of those published results. And one of the uh, I would say risk or danger is the feedback loops. If you have never heard about it, is that once you get to used to have these very easy accessible tools, and you're always stuck into that, right? You always wants to use it more, just TikTok, whatever, right? You probably see a lot of news on that. This is actually driven by the algorithms and to predict your behavior, which is mathematical models predict your behavior based on your own data. So essentially, every one of us here, if we use those social medias, being able to providing predictions of the behavior in the next moment or in the next hour. So it will definitely provide the videos actually compensate on whatever you want to see, but also it brings you only the videos you want to see, or advertisement gonna trick you to buy something or participate in something. We have to be really careful about it because once you have that down spiral, your psychological cycles will change, and I think it's really important for us to keep in mind that to come back and do our own outside activities and other things for that particular reason. Um, for the positive side, I would mention that it definitely gonna, if you use it well, definitely gonna change a lot of the way how people work. If you go into the large companies, even smaller companies, buying AI models or AI machines help them to improve, to maximize their efficiency by hiring less people or fewer people, or by doing more things with the same amount of people. So I would say um, we don't know the impact yet. It's just started. Probably the burst of the of use of AI started about 5 years ago, I would say. We still don't know the fully either potentials or the either the risks or the benefits yet. So yet to be seen.
Yeah, I completely agree. I think AI is just starting to transform the medical field, and like over the next few decades, we're definitely going to see a lot of advances in the healthcare field, but it's probably pretty hard to predict right now. But like I remember one time when I really saw the power of AI in like my own work was after I had run an experiment and I had gotten the data, I was just talking over the results with my boss. And we usually will like interpret the results and kind of come up with hypotheses for why we think the results turned out a certain way and kind of plan out like, okay, how are we going to plan our next experiment? Like, what conditions are we going to test? And I remember we just put in our results into ChatGPT and it was almost able to come up with like the exact same results that we had interpreted that maybe took us like 1 or 2 hours. Like it came up with in like 5 seconds. So I think that was just like a crazy realization. Because obviously everyone's using AI now, but to like see it just like do what took us like 2 hours that quickly, it really shows the power of it and like interpreting data, which is huge for any kind of therapeutic that's being developed, and helping test that therapy. So I could definitely see advances of that in the future. And I think another area that I've just been reading about that sounds super interesting to me is like personalized medicine. I've heard about AI being used to like analyze patient data, like their genetic information and their lifestyle factors, and like helping doctors create like a customized treatment plan for patients. Like I've heard about it for the use in like cancer therapy, and it's helping doctors kind of create like a personalized treatment for each patient instead of using like a one size fit all like chemotherapy regimen. So I could also see AI kind of being a tool for doctors to use in the future. I don't think it's going to be a replacement for doctors, but I could definitely see it helping their work and making it more efficient.
Yeah, definitely. I mean, like personalized medicine is something I've always been interested in. And I think it's pretty incredible how AI can like increase the efficiency of certain things. But I think it's also really important to remember that, as Harold said, it's a double-edged sword. There are both negative and positive effects to it. Um, and I think one big thing that I've noticed overall is like, especially taking stats this year, the data that you have really matters. And if the data is biased, for example, in this case, the AI will be biased, which will come up with in the context of personalized medicine, maybe treatment plans that aren't great for certain populations, for certain minorities, because certain like the data relies on, majority data. So I think it's really interesting how both things are brought up because people often think of either AI as all bad or all good. They don't consider both the negative and positives. And then this is our last question before we go into the break-in audience questions. But aside from AI, what are some relevant advancements in medicine and how does math play into these?
Yeah, so I would say go back to, I'll break it into two parts. One is medical research, the other is drug development. So in medical research, I think we have there are trends that now we are having a molecular level, which is more precise on describing using either mathematics or mathematics combining chemistry or other type of domain knowledges to describe how our organ works, including the genetics part of it. How do you modulate and how do you build animal models or the dish models, which is petri dish, right? You grow some bacteria, you can grow even organs out of it. So, medical research is advanced dramatically. And the reasons being we have these powerful machines, which is intersections with the computer science, algorithms, as well as mathematics, which are on the foundations of those models are being built. Um, the a little bit dark side of the building the models is a lot of the models are machine learning models or the especially large language models. You probably heard a lot about that is black boxed. we don't quite know how they work. Is the conclusion was based on whatever the accumulative knowledge is, or collectively from the data, the particular collections of data we have from literature, from language. But we're not so sure, because sometimes when you when you enter the same question, you get slightly different answers. It is okay for write an email, but think about it if you're doing experiments on the organ, and a little bit different will have a huge implications later on downstream. For the medical research, usually we want to limit those uncertainties and risks, and being able to evaluate what are the risks are, because essentially if the compound is successful, it has to be put in human being. So we have to be really careful about that. So that's actually a way into the drug development, where there is a debate right now on how to leverage the AI without being by by increase the risks from the clinical trial participants. We want to leveraging AI, but we don't want to put our patients in danger. So that requires a collaboration among scientists who understanding. Also, computers, mathematicians, statisticians to design the pyramids, how to understand algorithms, the right. If you study theory, you have a deterministic. If something that go on the consequences, so we have to understand those caveats before we actually put something in practice. Third one is really the conversation among all these domains, because one domain will help you to address one question, and the question may be also very complicated that one domain cannot really answer. For example, if you build a ship, right, you probably need tons of engineers and also designers and also captains and also other expertise to put them together. It's the same thing when you're doing drug development. You need people to understand basic science. You need people to understanding chemistry because you're making compound, and you need people like me to understanding the data to help them putting things a little bit together. And also you need clinicians who run the clinical trials to make sure we're ethical. The clinical trials on ethical sense, and it's providing the best values and best lower the risks of the patients, but providing the best values of the treatment effects. And then other thing is we have to be optimistic, because it's a highly failure rated industry, right? Not everything you build, and I would say 80% you try will fail. And only a few actually candidates will move into clinical phase later on, injecting to body or being taken by people. So I have to be careful, and I think the way to stay relevant to study math, you can actually play a lot of roles during this journey, no matter it's a medical research, helping formulate the problem, or maybe even solve the problem in collaboration with others. Or if you want to go to industry, specifically in pharma, and your mathematical weapons you learned will help you to get into the core of the problem much faster. And hopefully, you will pick up the working knowledge of other domains quickly, so that you can have a fair communication with other members in the team. I should emphasize again, mathematics, statistics alone, unless you want to be a professor, the knowledge alone will not get you too far. I will emphasize again three times. And please do consider, when you have a chance, especially when you're early in your career, your college life, try to use your mathematical brain, given that is helping others solve the problem, or given that it's joining a conversation, building a project. Try to use your mathematical sense. Try to explain well of your mathematical sense to others. That will help you a lot, and that will drive you a long way.
Yeah, I think honestly any relevant advancement in medicine probably had a huge like our math had a pretty huge role to play in it. I would say one of the main ones that stick out to me is probably the development of mRNA vaccines, like the one for COVID-19, because like designing an mRNA vaccine requires a lot of mathematical modeling. Like researchers will predict the structure and like the behavior of the proteins that they're using for it, like using mathematical models. And so I think it's super interesting because you probably don't think that about like mRNA vaccines, like how much math goes into it, but there actually is a lot. And math made that whole process of like developing the COVID-19 vaccine like so much faster, which was really necessary in that state of emergency the world was in. And like without math, it would have taken so much longer to find a vaccine to treat people. And I think another treatment or that stood out to me was probably the CRISPR gene editing that I've already mentioned, because I think math was also super important in this, like bioinformatics tools that are used to kind of map genomes and model how the gene edits like will behave are super important. And again, without math, that just wouldn't have been possible. So you can see that there's just a lot of overlap between science and math. As I've been emphasizing this whole time. And it's really important to not underestimate the role of math in science, because I think it just makes like the development of medicine so much more precise and faster and safer. And so it's definitely important to just keep that in mind.
Yeah, I feel like we as a society just really overlook like how important math is. Like math alone, like Carol said, won't really get you far, but math with other fields, like Viva said with the vaccine, with the COVID vaccine, like it's math with these other fields working together that make these advancements possible, which I really feel like we just overlook with our education system and like as a society.
Yeah, definitely. And like math is definitely like I would say like a foundational tool in terms of all of these things, helping to build, the vaccines, as you said, Viba. And then also like not only on a technical sense, but also, on more of a mindset sense. Like Harold said, thinking more abstractly about how to approach different problems, what the problem exactly is. All of those things kind of play together. And I think math is such a big part of that people, as Ria said, tend to overlook.